Hey chemistry students, this is Mrs. Miller, and today we're going to be talking about significant figures. Sometimes we shorten that up and we just say Sig Figs, but Sig Figs is a tougher term for some students to grasp onto. It'll take a little bit to understand these rules, but once you get them, it'll make it far easier in the long run, and we will continue to use Sig Figs all year long. So be sure that you understand these rules. In past science classes or maybe even math classes, you would have been asking your teacher, what do you want me to round to? How many digits do you want past the decimal place? Well, there's a reason why we use Sig Figs in chemistry and a lot of other higher level science courses. So what Sig Figs allow us to do is to be as accurate as possible without any guessing of digits. One big thing that you guys need to know and understand is that calculators do not use Sig Figs. A calculator answer and a Sig Fig answer are two very different things. Calculator answers are usually much, much longer and have lots more decimal places than a Sig Fig answer does. So what happens is we're going to use the values from the original problem to calculate an answer, and then we're going to figure out what that proper Sig Fig answer is going to be. This also helps to ensure that there's only one right answer to anything, and you never have to ask your teacher what to round to. So by the end of this lesson, what we want you guys to be able to do is to simply identify how many Sig Figs are in a specific number. We have 6 rules that we're going to get through with our Sig Figs, and these are rules that we will follow from today until the last day of school. So these rules are going to be really, really important for us. I highly suggest writing them down in multiple locations. Maybe if you get a study sheet for your tests and things like that, that you write these things down with some good examples. So there are 6 of them. Our first one is our easiest one, and then our 6th one we get a little bit more difficult. So we're going to start off with number 1. Non-zero digits are always significant. So what is a non-zero digit? That's 1 through 9. Any number 1 through 9 is a non-zero, get it? So those are always going to be significant. So when I look at this value, 1.324, I can look at that. I know the 1 is significant, the 3, the 2, and the 4 are all significant because they are non-zero digits. So this has 4 Sig Figs. Next up, when I look, leading zeros are not significant. So what is a leading zero? That would be a 0 in front. So when I go ahead and I look at this value right over here, 0.067. The first 2 zeros are what we call leading zeros, and we know from this rule leading zeros are not significant. There's nothing significant ahead of them. So this one and this one are not significant, but the 6 and the 7 are because of Rule 1 stating that non-zero digits are always significant. So the number 0.067 only has 2 Sig Figs because of those leading zeros. Next up, we have sandwich zeros are significant. So a sandwich zero is exactly what it sounds like when we sandwich something between other significant numbers. From this number, 102, we know that non-zero digits are always significant. So I know from this that the 1 is significant and the 2 is significant because they are non-zero. In this case, this 0 is what we call a sandwich zero. It's between 2 others. So this number has 3 Sig Figs. So as you guys can see, that's different from the leading zeros. We have nothing significant ahead of it, but in this case, we have something significant ahead and behind, so that's why we call it a sandwich zero. We have 3 more here. So zeros after non-zero numbers and a decimal are significant. So this one is important that you have to cover both steps. Zeros after non-zero numbers and a decimal are significant. So as I start to look at this number, we have 7.800. We know that the 7 is significant based on Rule 1. Non-zero digits are always significant. We also know that the 8 is going to be significant because it is a non-zero digit, and we know that those are always significant. So now it's these pesky zeros. As we saw from Rule 2, sometimes they're not significant, but Rule 3 said that sometimes they are. So the big factors here, first we're going to look, does our 0 have a non-zero number in front of it? So are these zeros after a non-zero digit? Yes, they are. So because the 7 and 8 are ahead of them, that is satisfying the first part of this rule. But it has two parts to it. Is there also a decimal in front of them? So when I look right here, yes, there is a decimal. So we can check off both parts of this, and that means that these guys are significant. Ooh, that's not going to fit. Sorry, that looked like crap. But when I look then, the 7 and the 8 are significant because of Rule 1. And the two zeros are also significant because they are after a non-zero number, the 7 and the 8, and a decimal's in front of them. So this has 4 Sig Figs. Our last two rules, we have zeros at the end of a number may not be significant. So we're going to use the same value, 560 and 560 with a decimal place. A decimal point placed after a 0 makes it significant. So I'm going to start by looking at my 560. So 560. I know that my 5 is significant because of Rule 1. Non-zero digits are always significant. I know that my 6 is also significant because non-zero digits are always significant. And then I have this 0. So are you significant? Let's read that last sentence again. A decimal point placed after a 0 makes it significant. So there's nothing after this, so this 0 is not significant. So 560 with no decimal place is 2 Sig Figs. However, we know that the 5 and the 6 in this case are already significant because of Rule 1. Non-zero digits are always significant. But now we have this little decimal place. A decimal point placed after a 0 makes it significant. So that means this 0 is also significant. So we have 3 Sig Figs here. So it's that decimal place that really is the deciding factor. Is that 0 significant? Is it not? Our last rule here is a 0 with a bar over it is significant. So here I have my value of 16,000. I know that the 1 and the 6 are both significant because they are non-zero digits, and we know that those are always significant. This rule states that a 0 with a bar over it is significant. So this guy right here is also significant. So then the question is, are these last two zeros significant? Well, there is no decimal place after them. So these two zeros, they have no bar and they have no decimal place, so they are not significant. Therefore, this has 3 Sig Figs. I know that was a lot of information, but we're still going to practice. Another thing that you guys need to be able to do is properly round using Sig Figs. So we have to be sure that we remember how to round answers. And we know that if a number has a 5 or greater, it causes the number to round up. That means if it is 4 and below, we round down. All right, so when we go ahead and we look at this, now what we're going to do is we see the number 14.56. What we want to do is we want to round to 3 Sig Figs. All right, so when I look at this, I know that right now this value has 4 sig figs. Based on rule 1, all non-zero digits are significant. So right now we have 4 sig figs. We want to round that to 3. So we're going to go ahead and we're going to look at our third sig fig, and we're also going to look at our fourth sig fig in this case. So this fourth sig fig impacts the third. Because it's a 6, it's going to cause that 5 to round up. So if I go ahead and I round that up, 14.56 rounded to 3 sig figs ends up being 14.6 because of this 6 making that 5 larger. Now if I look here, 273.5, again, we have 4 sig figs because they're all non-zeros. I only want to round this to 2 sig figs. So this time, I'm going to look at my second, and it can only be impacted by the third. We're not even going to care about this 5 back here. So what does this 3 to the 7 do to that 7? Well, the number is 4 and below, so we round back down. So we end up with a value of 270. Notice that there is no decimal place here. If we put a decimal place there, the reason why that would be wrong is this has 3 sig figs because of that decimal. This one only has 2 sig figs because of the lack of decimal. Our last one is 16.4589 rounded to 4 sig figs. So what we're going to do is, again, we're going to look at our fourth and our fifth sig fig only. We don't even care about this next one over. What is this 8 going to do to my 5? Well, it's going to cause that number to round up. So when it does that, we end up with a value of 16.46. Notice we don't record any other values here because those would also be significant. So that one only has 4 sig figs. So that's how you round. 5 and above, round up. 4 and below, round down. Here we have a little test of how many sig figs are in each of the following numbers. What I would like you guys to do is to try this on your own first. Just write next to each of those numbers how many sig figs you think that are there, and then pause this video right now so that you have time to do that, and I'll show you how I would go through and do it then. So pause the video and we'll come back. All right, so if I were doing this, the first thing that I'm going to look at is number 1. I know that these 3 values are all significant because they are non-zero numbers. So that means, are these zeros significant? Well, they are not because they are leading zeros. There's nothing significant ahead of them. So this one has 3 sig figs, and I'm lazy and I'm just going to abbreviate that as SF. Next one, 612. This one has 3 sig figs. The reason why that is because all 3 are non-zero digits. Number 3, when I look at this one, I know the 9, the 3, and the 1 are all significant because they are non-zero digits. So then I need to decide on the 0. Is it significant? Well, yes it is. And the reason why that is, so we have 4 sig figs, is because this little guy is a sandwich 0. Our next value, we know that the 7 and the 2 are both significant because they are non-zero values. Then we need to decide on these other zeros, are they significant? Well, if you go back to your list of rules, something that makes these values significant as zeros is a decimal place after them. Do we see a decimal place there? No, we don't. So this is just 2 sig figs. These other zeros are not significant. However, when we look at number 5, we know the 8, the 9, the 4, and the 5 are all significant because they are non-zero values. Then we have 3 zeros here with a decimal place. That decimal place plus having something significant ahead of them, so you need both, makes all of those significant. So this has 7 sig figs. Number 6, when I go ahead and I look at this one, We know the 1 is significant because it is a non-zero digit. We then have these 2 zeros hanging out of the back. These guys are significant, and there's a reason why. They have a decimal place in front of them, as well as something significant. So what about this last little 0 right here? Well, it actually becomes a sandwich 0. So this one has 4 sig figs because it's sandwiched between these 2 that are significant and the one that is also significant. Number 7, how many sig figs do we have here? We know the S and the F. I'm sorry, the 7 and the 5. Wow. Are both going to be significant because they're non-zeros. We know that this value with the bar is also significant because the bar makes it so. And that means that this other 0 becomes a sandwich 0, but this little 0 doesn't have a decimal place, so we have 4 sig figs. Our last 2, we know that all of these values are non-zero digits, so those are going to be significant. And then we have to look at the 0 out in front in this case. We know that a 0 in the front is what we call a leading 0, so it's not significant. So this one has 5 sig figs. So we know that this guy is a leading 0, so it's not significant. But this guy back here has something significant ahead of it, plus a decimal place, so it's 3 sig figs. So to get all of those rules like I was just talking about, you can go ahead and you can look in this area. So if you want to just double check all those, go ahead, pause the video, and take a look. So here is our last little practice problems that we're going to look at. Again, I just want you guys to identify how many sig figs you are seeing. So in this case, this value has 5 sig figs. The reason why that is 4 of those values are non-zeros, and this 0 is a sandwich. As we move on, what we're going to see here is, again, we have 5 sig figs. The reason why that is all these values are significant. This 0 has something significant in front of it, so sig fig in front of it, and a decimal. Our next one only has 2 sig figs. And the reason why that is because these guys are leading zeros. So if you want to pause and try these other 6 at the end, go ahead and do that. Otherwise, I'm going to continue. So next, right here, we have 1 sig fig. These guys, no decimal. This one has 2 sig figs. This guy is a leading 0. 3 sig figs. This guy is a sandwich 0. Here we have 3 sig figs because we have something significant. And a decimal in front of it. Here we have 1, 2, 3, 4, 5, 6 sig figs. The bar makes that guy significant, but this guy is not because it has no decimal. And last but not least, we have 4 sig figs here because we have a decimal and sig fig in front. So I know that's a lot of information. You guys are going to get a lot of practice with sig figs. If you have any questions, let us know.